Okay, everyone, let's take a look at Chapter 7 PLC and System Interfacing. Primary systems transmit and control the movement of energy. Electrical systems use alternating current AC or direct current DC to produce power. Electronic systems monitor and control electricity to send and/or receive information, produce sound or vision, store data, control circuits, or perform other work. Fluid power systems produce work by transmitting fluid under pressure through pipework. Mechanical systems transmit power using gears, belts, chains, shafts, couplings, and linkages. Informational systems display electrical, electronic, fluid power, and mechanical quantities and conditions to indicate the status of a circuit, process, or application. Interfacing systems interconnect primary systems of various types. Combination systems, such as industrial robots, interconnect two or more primary systems such as hydraulic, pneumatic, mechanical, electrical, electronic, digital, and welding, combining the individual advantages of each system to meet the requirements of a given application. System interfacing permits devices and components of various levels of voltage, current, and power to work together as a system. Circuit conditioning is required anytime the existing electrical power is not at the proper phase, voltage, or current level for the application. Interface devices are required anytime an input device or output component is not directly compatible with a PLC. Interface devices change or condition a system in a variety of ways. Basic electrical circuits must include a source of electricity, a method of controlling the flow of electricity, and a component that converts electrical energy into some other usable form of energy. A circuit must also include protection devices to ensure that the circuit operates safely and within designed electrical limits. Basic PLC-controlled circuits with multiple loads wired in parallel have the loads wired separately to the PLC output terminals and output terminals programmed to be parallel. Basic circuits are improved by adding additional protection, instrumentation for monitoring circuit parameters, finer control, or by interconnecting all basic circuits into a system. PLC and PCs are interconnected through communication lines to form various types of levels of networks. Sensors and switchings are typically input devices to a PLC, with lighting, motors, and information displays being typical output components for a PLC. Relays, contactors, and motor starters are the most common interface devices used to control high-power loads. Electrical mechanical relays have sets of contacts that are closed by magnetic force. Solid-state relays have an input voltage range such as 3 volts DC to 32 volts DC. That allows a single solid-state relay to be used with the most common electrical circuits and PLC output modules. Types of relays used depend on the life expectancy, electrical requirements, and cost requirements of the application. Any load that can cause a problem to the output section of a module of PLC must include an interface between the PLC and the load. The output side of a solid-state relay can be used to control high-voltage medium power loads such as three-phase heating elements. Contactors are designed to control high-power non-motor loads. Contactors allow PLC output circuitry to be rated much lower than the loads that the PLC is controlling. Magnetic motor starters use a small control current to energize a coil to send high power to a motor. When the coil of a motor starter and the control circuit require lower voltage, a step-down transformer is used to reduce the high voltage to a low voltage. Electric motor drives control motor speed by controlling the frequency of the electricity to a motor. Any type of switch, contacts, such as push buttons, pressure switches, PLC output contacts, can be used to control an electric motor drive. Alright everyone, that was it for that chapter. Next will be Chapter 8, PLC installations and startups, and I'll see you over there.